Hello, dear students. I want to explain or to speak about stoichiometry because it is a very important concept that is used in chemistry. Let's begin by making the difference between physical and chemical changes. In a chemical change, we cannot go back very easy. And we have always new products. Sometimes the reactants are over during the reaction. And generally we have or heat or light or sound that or a gas that is released. Sometimes we produce electricity, sometimes a precipitate is formed. Example, when we burn wood, well, we produce heat and light. And the final product is not good at all. In a physical change, it's different. We don't have new products. We only go from one state to another. For example, water can be ice, could be liquid, or could be a gas. But in these three states, water remains the same substance. Then the change in the state of a substance is just a physical change. We have different kind of chemical reactions. Synthesis is when two different reactants join together to make one new substance. This is also known as combination. The opposite is when this product breaks down into different simple substances. This is known as decomposition. When we have a substance that is composed of two or more elements, and we have one substance that is made of only one element, and this element replaces one of the elements in the compound substance, we say that this is a single displacement reaction. When we have two compound substances and one element in one replaces another element in the other, and this element at the same time goes to combine with the other element in the second substance, we say that we are in front of a double displacement reaction. One important thing is how to balance a chemical equation. For example, here we have this compound that is made of 3 atoms of carbon and 8 of hydrogen that is reacting with dioxide to make water and carbon dioxide. You have to realize the number of atoms in the reactants and the number of atoms in the products. For example, here you have 3 atoms of carbon, and here in the products only 1. 8 hydrogens in the reactant and 2 in the products. 2 oxygen in the reactant and 3 atoms of oxygen in the products. So you begin by trying to balance those elements that are not or doesn't have the same number of atoms in every side of the reaction. For example, here you have a hydrogen and only two here, two oxygen here and three oxygen here. But we always leave hydrogen and oxygen to the end, and we begin from the other types of element. In this case, we are going to begin by carbon. Well, if you multiply here by a 3 in the carbon dioxide, you will have 3 atoms of carbon in the reactant and 3 atoms of carbon in the products. But as this oxygen is affected by these 3, you have to multiply 3 by 2, 6 atoms of oxygen plus the 2 that you had before will make will make 6 atoms, 6, and 1 will be 7 atoms of oxygen. Let's see what to do. Now you have 2 hydrogen here, and you have 8 here. If you multiply here by 4, you will have 8 hydrogen and 8 hydrogen. So what to do in this case? Now you will have 8 oxygen, and 3 times 2, 6 will be 10 oxygen. If you multiply here by F5, you will have 10 oxygen too. And at the end, you have 3 carbon and 3 carbon, 8 hydrogen and 8 hydrogen, 10 oxygen and 10 oxygen. In this case, when you have the same number of atoms in the reactants and in the products, you say that the equation is balanced. What are the parts of a chemical equation? Well, this number in front of the substances are known coefficient, and these are the subscripts. You have the chemical formulas and you have an arrow. The arrow means yields. The substances before the arrow are the reactants, and the ones after will be the products. In a chemical reaction, we have that the mass cannot be created or destroyed. In other words, this is the law of conservation of mass. So if you have 30 kilograms plus 1 kilogram of fire, at the end you have how many? 31 kilograms in the reactants. If you go to the products, you will have 28 kilograms of ashes and 3 kilograms of smoke. If you add 28 plus 3, you will get 31. Then you will have 31 kilograms at the end from 31 kilograms at the beginning. Mass is not created, not destroyed. Sometimes we have a equation that happens in aqueous solution that is represented by this subscript. In this S here represent a solid, and an L represent liquid, and G represents a gas. In this case, you begin from the molecular equation, and you see that all the substance in the aqueous solution can be converted into ions, while the solid and the gas and the liquid remains as a compound. Then you can break into ions silver nitrate, potassium chromate, and potassium nitrate. In this case, you can see that silver is here in form of ion, but here is in form of a solid. And chromate here is in form of ion, and here in form of solid. But potassium remains the same in both sides of the equation, and the same with nitrate. So nitrate and potassium are spectators, and you can cancel them, and the net ionic equation will be 2 ions of silver in aqueous solution plus 1 ion of chromate in aqueous solutions till silver chromate as solid. This is the net ionic equation. A very important concept in chemistry is, what is a mole? Well, a mole is a very big number, bigger than the number of pieces of sand in the Sahara Desert, more than many of the number that you know. And we can say that 1 mole, that is what we call as Avogadro's number, is 6.02 times 10 to the 23. Don't forget about this number because we are going to use it a lot in chemistry. We can go from mole to number of atoms, and we can say that 1 mole has 6.20 times 10 to the 23 atoms of anything. It could be oxygen, hydrogen, no matter what type of atom it is. But also, we know that 6.02 times, here is a mistake, sorry, is 602, not 620. 602 times 10 to the 23rd atoms of carbon is 12 grams of carbon. Then you can say that 1 mole, for example, of helium is 6.02 times 10 to the 23 atoms of helium, or is 4 grams of helium. Or also you can say that 1 mole of helium occupies a volume at ATP of 22.4 liters. these conversions are using chemistry, and all these calculations are known as stoichiometric calculations. Let's see an example. How many atoms are in 3.5 moles of sodium? You say, well, what is given? 3.5 moles of sodium. And you know that 1 mole is 6.02 times 10 to the 23 atoms of sodium in this case. You plug this way, or you set this way the equation in such a way that you can cancel mole with mole. And when you multiply and divide, you get that the answer is 2.1 times 10 to the 24 atoms of sodium. That is what you are asked for. But also you can go from atoms to mole. In this case, what is given? 4.78 times 10 to the 22nd atoms of silver, and you want to know how many moles you have. Then you know that 1 mole is 602 times 10 to the 23 atoms. You can cancel atoms with atoms. You multiply and you divide, and the answer is 0.0794 moles of silver. Look at this. You begin with 3 significant figures and you finish with 3 significant figures. In this case, you have to go from moles to grams. In this case, is given the number of moles of a substance. And then you have to use the molar mass of this compound. You know that sulfur is 32 grams. 1 mole of sulfur is 32 grams, and 1 mole of oxygen is 16. But you have 3, then is 48 plus 32 is 79.97. So 1 mole of sulfur trioxide is 79.97 grams of sulfur trioxide. You set the calculation in this way in order to cancel moles with mole. And when you multiply and divide, you get this number. 3 significant figures at the beginning, 3 significant figures at the end. In this case, you have to go from moles to grams. Well, you know that the given number is 2 moles of water, and you know that 1 mole of water is 18 grams of water. Then you cancel moles with mole, you multiply and divide, and you get 36.0 grams of water. In this case, it's not correct. Why? Because you have 2 significant figures in the given number, and the answer will be only 36 grams of water with 2 significant figures. We have different kind of psychometric calculations. We can go from mole to mole, mole to mass, mass to mole, or mass to mass. Let's see everyone. For example, in this case, you have how many moles of water can be obtained from the reaction of 4 moles of oxygen. Be careful, you have to begin from the chemical equation balanced. if the equation is not balanced or the calculation will be wrong. So what is given? 4 moles of oxygen. What is needed? Moles of water. You know that you have 4 moles of oxygen, and you know from the chemical equation that 1 mole of oxygen produces 2 moles of water. You will use these coefficients to make a conversion factor. And you set this way in such a way that you can cancel mole of oxygen with mole of oxygen. Then you multiply and divide, and you get 8 moles of oxygen. One significant figure at the end. In this case, you begin from 4 moles of oxygen, and you need to know the grams of water. Then you have to go from moles to mole, and from mole to gram. The first part is the same one that we have seen before, but now you have to go from moles of water to grams of water. And you know that one mole of water is 18 grams of water. You set this way in such a way that you can cancel mole of water with mole of water. Now you multiply and then you divide and you get 144 moles of water. But what happened? The given number has only one significant figure, and you cannot report 3 significant figures. You say, what is the closer number to 144 with only one significant figure? Oh, it's 100. Then this is the answer for this problem. In the third case, you have to go from grams to moles. Then you say 64 grams of oxygen, how many moles of water will produce? You say 64 grams of water. You know that 32 grams of water is 1 mole of water. Then in this case, you convert the grams into moles. And using the coefficient in the chemical equation, you can go from moles of oxygen to moles of water. You cancel grams with grams, moles with moles, and you get what is you're asked for, moles of water. Then in this case, you multiply and you divide and you get your answer, 4.0 moles of water. 2 significant figures in the given number, 2 significant figures in the answer. In this case, you have to go not to moles of water, but grams of water. Then you add an extra factor. 1 mole of water is 18 grams of water. You cancel moles of water with moles of water, and then the answer will be in grams of water. You multiply and you divide and you get 72 grams of water. 2 significant figures in the given number, 2 significant figures in the answer. Well, what is the limiting reactant or reagent? It's a reactant that determines how much of the products are made. In this case, you begin with 1, 2, 3, 4, 5 hot dogs, and only 1, 2, 3, 4 bonds. The limiting reactant in this case are the bonds, because we can make only 4 hot dogs. Then you will have an excess of 1 hot dog. Then the bonds are the limiting reagent, and the number of product that you get is the theoretical yield. Example, you begin with 50 grams of silver nitrate and 50 grams of hydrogen chloride. How many grams of silver chloride can you make? Then you made two calculations. First, from 50 grams of silver nitrate, how many moles of silver nitrate you can make? This is a problem that we have seen before. Then you say 1 mole of silver nitrate is 143.5 grams of silver nitrate. You cancel grams of silver nitrate with silver nitrate grams. You multiply and divide, and you get 0.35 moles of silver nitrate. From 50 grams of hydrogen chloride, you can get 1.37 moles of hydrogen chloride. So you compare this with this, and you see, oh, this, in this case, I get least moles of silver nitrate. So silver nitrate is the limiting reagent or reactant. And at the same time, the number of moles of silver nitrate will be what we call theoretical yield. Well, that's all for today. I hope you understand. If you don't, please don't hesitate and ask me.